Okay, the next example, we have this picture. The only thing this is giving us is that the mass is 20 kilograms. So that's not a weight, it's a mass. That's m. M equals 20. The question is, if the frequency of simple harmonic motion is 2 over pi cycles per second, then what is the spring constant K? Well, let's think about it. Let's start writing some stuff down that we know. F. What's the formula for F? It's 1 over T. It'd be omega over 2 pi. Because that's the reciprocal of capital T, the period. That's the formula for F. But we're told it's equal to that. Okay, so these two are equal to each other. We could cancel out the pi's. We could, let's see, omega over 2 pi equals that. So if we just cross multiply, we get 4 pi equals omega pi, right? If those fractions are equal, the cross products are equal. So we get omega equals 4. Now, does that help us? We want the spring constant K. Well, with that we can get K over m was omega squared, right? So omega squared equals K over m. Well, omega is 4. So 16 equals K over the m is 20. So multiply both sides by 20. K equals 320. That's the spring constant. Since, I don't know if we'll need it down here or not, but since we know omega, the differential equation would be x dot dot plus omega squared x equals 0. So we can solve it. X dot dot plus omega was 4, so 16x equals 0. I'm just going to circle it. Not sure we'll need it in the next example or not, but that's not the solution. I hope I didn't say that. That's the differential equation. The solution would be, let's see, x of t equals c1 cosine let's see, that would be, the characteristic equation would be m squared plus 16 equals 0. So you're going to get plus and minus 4i. So, oh, we already know, I'm sorry, omega is 4. So 4t plus c2 sine 4t. We wrote that down earlier. When you know omega, you know that just plug omega in there and there, and we've got the solution. Again, that wasn't asked for yet, but we might need it down here. Actually, I don't think we will. If the mass is 80 kilograms instead of 20, what's the frequency of, let's see, frequency is omega over 2 pi, and that's what we're looking for. We're looking for F. Omega is that, and do we know both of those? Let's see, we do know the spring constant. So we get omega, we can solve for omega then. K is 320. And what did we say? Mass is going to be 80 this time. So omega is, under the radical we have a 4, so it's just 2. All right, so if that's the case, then frequency equals 2 over 2 pi. So frequency equals 1 over pi cycles per second. And the only thing that would change in that with the solution would be that the omega, instead of 4, we'd have a 2 here and a 2 here, if I wanted to write down the solution there. But here's the answer to the question.